In this presentation, I'd like to talk about series and parallel circuits from the point of an HVAC technician. So far, we've looked at circuits that have one path for electricity to go as in a single switching device. However, the majority of circuits you work with as an HVAC technician will be more complex. We must understand the two ways of circuits being designed, and we got to start understanding the theory behind them. Series circuits exist when the flow of electrons or current must pass through a series of components. Switches that control loads are normally wired in series with these loads. In other words, every switch has to be closed for the load to operate. In this case, we have two loads, B1 and B2. They are in series with each other. You have switch 1 and switch 2. They are in series with each other and the loads. Both switches must be closed and both loads must be operational for this circuit to work. Switch 1 is in series with switch 2, which is in series with B1 and B2. If any one of these components in the circuit is open or fails, the remainder of the circuit will not work. Loads in series split the source voltage based on their resistance. Neither B1 or B2 is getting the full source voltage. The amperage is the same through the entire circuit. The total resistance is the sum of all the individual components' resistance. In the HVAC industry, it's rare to see loads in series. It is very frequent to see switches in series. Both switches must be closed to provide a path for electricity. In a series circuit, any open will cause the circuit not to work. To troubleshoot a series circuit, start by making sure all the switches that you can physically close are closed. Check the voltage across the source. Make sure you have source. Now check the voltage across the first switch. We get 0 volts. It's closed. Continue moving on using the hopscotch method until you find anything that is open. Okay, we're continuing to move through our circuit. We're now at the source or line side of B1. We're between B1 and B2. And we have the voltage at the neutral side of the circuit. In that case, the circuit was good. When troubleshoot a series circuit, if you get source voltage across any switching device, that is the switch that is open. When troubleshooting a series circuit, if you get source voltage across a load and the load is not operating, the load is bad. It's acting like an open switch. Parallel circuits are more common in the industry for loads. These are the circuits that do the work. All loads in a parallel circuit receive full source potential. That's voltage. Parallel circuits exist when the circuit has more than one load, but none of the other loads receive voltage from another load. If one load burns out or goes bad, the remaining loads will continue to operate. All loads in a parallel circuit get full source voltage. The total amperage of the circuit is the sum or add up all the amperages of all the loads. This is an example of one switch controlling two loads in parallel. Both loads B1 and B2 are going to get full source voltage, whatever L1 to L2 is. This is two switches in parallel controlling two loads in parallel. If switch 1 is closed, B1 is going to get voltage. If switch 2 is closed, B2 is going to get voltage. They're independent. Troubleshooting a parallel circuit is the same basic procedure as a series circuit. Start at the source. Make sure all switches you can control are closed. Take voltage across the source, 240. Then continue through, taking voltage across each switch and each load. Because each load should be getting 240. Each switch should have 0 across it. If you have a load that's not working but has source voltage, it's a bad load. If you have voltage across any switch that you think is closed, that switch is actually open. Might be a bad switch, might be a safety device. To troubleshoot, there's some basic rules. Start at source and work your way from there. There's no reason that if you don't have source you should even go any further. You need to stop and find out why. If you get any voltage across a switch, that switch is open or bad. If you get voltage at a load and the load is not working and has failed, replace it. Now, those of you working in the school are going to build and check a series circuit using your meter. Then you're going to build and check a parallel circuit using your meter. For those of you outside and doing this from distance, go around your house. See if you can find a parallel circuit. Hint, all of your light bulbs in your entire house are wired in parallel. See if you can find a series circuit. Those might be tougher to find because that's not normally used in residential. Be careful as you're using your meter. Don't touch any metal and make sure you are set on the right scale.